The security model in SQL Azure really isn't that much different from the security model that you know and love in on-premise SQL Server. It uses the regular SQL Server security model. It allows you to authenticate logins and map users to roles, and allows you to authorize users and roles to SQL objects. You also have support for standard SQL authentication logins, meaning you provide a username and password. The difference between SQL Azure and on-premise SQL, however, is that there is no Windows authentication. Right now, it just supports SQL Server authentication. But beyond that, the security model is extremely compatible with on-premise SQL. Let's talk about database sizes. You have two editions of databases in SQL Azure. You have a Web Edition and a Business Edition. For Web Edition databases, you have two sizes, 1 GB and 5 GB. In the Business Edition, you have 5 sizes, 10, 20, 30, 40, and 50 GB. You will be seeing larger database sizes in the future, but right now your limit is 50 GB. Now let's talk a little bit about on how those limits work. If you sign up for a 20 GB database, you're charged for a 20 GB database even though you might be using only 15 GB of size. Once you hit that 20 GB limit of data, your database goes into read-only mode. It will not auto-increment to the next size, which is 30 GB. Pricing for these databases really depends on the type of edition of database that you sign up for. Meaning, for example, a 1 GB and 5 GB database range from $9.99 a month to $49.95 a month. A business edition database ranges from $100 a month to almost $500 a month. And the number of databases you get really depends on the option you select when you're creating your Azure account. For example, the SQL Azure Development Accelerator Core option gives you one Business Edition 10 GB database for $74.95. One of the concepts when talking about moving your database to SQL Azure is the concept of scaling out. Another way of saying that is of the elastic provisioning of a database, meaning how do you create your databases on the fly and how do you scale out your databases? So do you just create your database and go with no VMs and no servers? You also have the pay-as-you-go business model, meaning if you don't need it, drop it. You also have the zero physical administration. This is a built-in high availability patching and maintenance solution. You also have database copy and the SQL Azure Data Sync solutions, which we'll talk about shortly. We need to talk about scaling options. And one of the key concepts of scaling is the concept of sharding and the sharding pattern. Sharding is really the linear scaling through database independence. There are no needs for distributed transaction in most cases. Sharding also introduces the concept of engineered partitioning, meaning do we build our own scaling out and partitioning functionality, or do we let the database do it in a completely transparent manner? And when we talk about sharding, we also have to talk about where that sharding is taking place. When we shard, we're doing connection routing. Where is this query being executed? On this shard? Is it being executed on that shard? Is it being executed against this database? So when we talk about sharding, we need to talk about connection routing. Where is this query being executed? We also need to think about the query and transaction scoping, meaning if we're doing transaction, if we're wrapping a query in a transaction, where and how is this transaction being scoped? A lot of us are used to distributed transaction. We think in terms of sharding as distributed transactions. But for some, this is distributed access. Fanning out queries can be an expensive computation, so we need to think about sharding in a more simple terms. So for example, I have an app and I have 5 databases. So in a normal situation, I might have an application talk to 5 different databases one at a time. So I might say, here's this query, go to this database, here's this query, go to this database type of thing. But from a sharding perspective, if I execute one query, that query might be executed against all the databases at the same time. This improves performance and allows for better manipulation of the data, meaning I can execute one query and that query is fanned out across all my databases. The data is brought back and aggregated and presented to me in my application. Let's take a look at a sharding pattern. For example, here I have Day Old Sushi Online, a single database that includes products, orders, and customers. The question is If I move this into Azure, how do I shard this data? And I actually have several options for doing that. One way of doing this is to create 3 different databases with customers in one database, orders in another database, and products in a third database. Another way we can do this is still with 3 different databases, but partitioning on a key. For example, in this case, we're partitioning on the customer's last name, where customer last name A through K goes in this database, customers L through Q go in the second database, and customers R through Z go in the third database. You'll notice in this pattern, however, both the customer orders and products are all in the same database. We're just partitioning, however, on the customer key. For example, maybe a customer ID, where customer ID is based on the last name, for example. So A through K, L through Q, and R through Z. So let's talk about some of the key SQL Azure Federation concepts. We have the federation, which represents the data that is being sharded. We have the federation key, and this is the actual value that determines the routing of the piece of data. For example, customer ID. We have what's called an atomic unit, and this is all the rows with the same federation key value, and these will always be together. You then have the federation member, or also known as the shard, and this is a physical container for a range of atomic units. And lastly, you have the federation root. This is a specific database that houses the federation directory. When you execute a query, it first goes to the federation root to determine where it needs to go to execute that query and get the data that you're requesting. So how does federating work? It's several steps. First, you have to create the federation and the federation tables. So for example, once you create your federation, you say create table orders and federate on customer ID. The key to this is that the federation key must be in all unique indexes, meaning it must be part of the primary key. And the value of that federation key will determine federation member. You also have reference tables. This is a standard create table where you're not federating on a specific key. In other words, if you specify create table without the federate on statement, SQL Azure will simply consider this a lookup table. And then you have what's called centralized tables, and these tables are created in the root database and help SQL Azure determine what to federate on and where to send your queries. So let's take a look at an example on how this would work. First, you create your database using the create database statement, and the next step is to create your federation. So in this case, you're saying create federation, orders federation, and then you specify the type that you're going to federate on. In this case, it's a big int range. Once you've created your federation, you use that federation to create your tables. For example, create table orders, federate on customer ID. Create table orders details, federate on customer ID. Create table zip codes, and since in zip codes we're not specifying the federate on, this becomes a lookup table. The key here in federating and sharding is that you need to somewhat denormalize your database such that customer ID needs to go in the tables that you want to federate on. Another one of the key concepts with federation is that you can split and merge. In other words, so you can say alter federation and the federation name split at 100. Or you can say alter federation and federation name merge at 100. This allows you to split and merge your federation, determine your federation sizes. Once you have created your federation and your federation tables and determined what you're federating on, this then has an impact on how you query. As normal SQL developers, we're used to saying select star from orders where order ID equals, or select star from customers where customer ID equals. But in the world of federation, this changes a little bit. Your syntax now becomes use federation, federation name, customer ID with filtering on, and then you execute. So the concept of now saying select star from kind of goes away when you're talking about federation. However, there are some benefits of using the federation. What does it give you? You are guaranteed to land in the correct federation member even if the data is being repartitioned. Meaning, if the data is being repartitioned based on load and you execute the query, your data is guaranteed to land in the correct federation member. And even with the filtering option set, your connection is scoped to the data that is part of, for example, customer ID equal 55, meaning that you no longer have to remember to include the filter in your where clause. So example, let's say we do select star from customer where customer ID equals 55. The where clause now goes away because we're just saying use federation, federation name, and specifying the customer ID. So the where clause now goes away. All right, enough about federation and scalability. Let's talk a little bit about backups. When dealing with backups, we're really talking about two types of dangers. We're talking about the disaster recovery type, and then we're talking about the rogue SQL developer who just executed a delete or update statement without specifying a where clause. These are the two kind of things that we need to solve from a backup perspective. However, currently in SQL Azure, there are no current backup features, meaning I cannot do a backup and get access to that backup file that we just backed up to. One of the things that we have not talked about, however, is the idea that a SQL Azure database is in triplicate. When I create a database, there are actually two more databases created for me. Now I have my primary database, but then I have two other databases that are always in sync with the primary database. When I execute a query against my SQL Azure database, it goes against my primary. I always have two other databases created in the same data center for disaster recovery and high availability. And let me give you an example. Let's say that primary database goes down for whatever reason. SQL Azure will actually route my connections to another one of those three databases and spin up another third database for me. So I'll always have three databases always in sync. This is what allows SQL Azure to provide a 99.9% SLA. Now coming soon, you will see the feature where one of those three copies will actually be created in a second data center. So for example, if that your primary data center ever goes down, your data is not lost and you can still work because your connections will be routed to that third copy in another data center. And this is what will allow SQL Azure to provide 4.9 SLA. But for right now, it's 3.9 SLA because all three copies are in the same data center. Now, this allows SQL Azure to provide high availability and disaster recovery, but really does not solve the backup problem. So from a backup perspective, this is a very high priority for the next version of SQL Azure. So for right now, you must provide your own approach. So you can write code that moves data from one SQL location to another. You can export that data to a file, or perhaps you can even use BCP or SSIS to get your data out of SQL Azure. Now recently Microsoft came out with a feature that's known as database copy, and what this does is it makes a transactionally consistent copy of your database to a new database with a new name on the same server or to another server. The great thing about this is there is no downtime on the source database. So you start the copy, your source database is still functional, and it's still writing, and it's still creating a copy of your database, and it is transactionally consistent, meaning it is transactionally equivalent at the end of the copy. Right now, however, this only works within the same data center, and you must have matching credentials on the servers, on both servers, if you are creating the destination database on a different server. You must have DB owner permissions on the source database and DB manager permissions on the destination database. Now this is great and it works fine. However, what it means though is that you are now paying for a second database. So how does the database copy work? It's actually pretty simple. It's just create database, destination database name, as copy of, and then specify the source database name. When you execute that, you can actually see the progress of the copy. You can go to one of the system tables and do a select star from sys.dm_database_copies and see the progress of the database copy as it's being copied. One of the key features of SQL Azure is a feature called the SQL Azure Data Sync. This allows you to sync data between two SQL Azure databases or between a SQL Azure database and an on-premise database. This provides an elastic scale, meaning the service scales as resources requirements grow. As your requirements grow, you can scale this service to meet your needs. And there really is no code, so you can set this up without writing any code. It's a wizard-driven functionality. You can easily define the data to be synchronized with just a few clicks. These synchronizations can be scheduled, and you can choose how often data is synchronized. And the SQL Azure Data Sync handles conflict handling, meaning it handles issues where the same data is changed in multiple locations. So you don't have to write any extra code to handle conflict handling. SQL Azure Data Sync handles this for you. And it does logging and monitoring. So you have an administration capability for tracking data and monitoring any potential issues. Now, right now, this is in CTP, but you can get to it through the SQL Azure Labs website. Right now, the SQL Azure Data Sync provides you to sync at a table level, but they're talking about providing, by the time of the release, the ability to synchronize at a column level. So again, you can do on-premise to cloud. I can sync SQL Server to SQL Azure, and the benefits include making cloud extension rather than a replacement. In other words, I can make my cloud scenario an extension of what I have on-premise instead of replacing what I have on-premise. And it enables me to move my workload to the cloud in stages, which preserves my investment in my existing infrastructure. And as my needs grow, this allows me to create new scenarios to span my enterprise and my cloud, so I can sync between my on-premise database and my SQL Azure database easily and effectively and expand as my needs grow. One of the other key features of the SQL Azure Data Sync, besides allowing SQL Azure to SQL Server Data Sync, there are other benefits. It allows me to share data with remote and retail offices, bringing data closer to the end users. Meaning if I have remote users, I can sync geo-specific data from on-premise to a location that is much closer to my end users so they can actually get to their data much easier. And this provides a lower latency for my end users, so data access does not require round trips. And it also provides higher availability, meaning my app still runs if the server is unreachable. And ultimately, this provides a reduced network utilization, so most of my data access is local, meaning I don't need to go clear across the network to get my data. I can access my data local because it's been replicated to a location much closer to me. So the entire concept of the SQL Azure Data Sync here is that using SQL Azure, I can sync between my on-premise to SQL Azure and from SQL Azure to a remote location that is much closer to my users. And the entire concept for the SQL Azure Data Sync is to provide an end-to-end scenario, meaning I want to sync between my on-premise application in the cloud, my retail and remote offices with the cloud, and including my offline applications. I want to be able to sync with maybe a SQL CE device or a handheld device, those type of applications that are offline or that can be taken offline. So when they come online, they can sync, I can take them offline and still have my data. So the entire concept of the SQL Azure Data Sync is to provide an end-to-end scenario. Doesn't matter where my data is, I can sync that data to my users, to my customers, to retail stores in any given scenario. Okay, in this first example, I'm going to illustrate how to do a database copy, and this is actually really easy. We don't have a large database to copy, so we're just going to use one of the databases we created earlier in our instance of our SQL Azure instance. So we're going to take our AppDev2 database, and we're actually going to create an AppDev3 database using the SQL Azure copy. So we'll open a new query window, and we'll simply do the following. Create database. We'll call this AppDev3. And we simply need to provide the as copy of, and we'll say AppDev2. From a database copy perspective, that's really all we need to do. So let's execute this. Oh, that's a good quote. So we actually must be in the master database to execute this. So let's actually change our context. Oh, let's copy this. We're going to create a new query window. We won't save that. We'll create a new query window. Select our master database. We're in the master database, so we'll paste that and let's run this. Command completed. Now what this says is the command is completed, so we're going to get the results back, but really what's happening is that the database copy is still going on. So we can actually look at, if we want to, select star from sys.dm database copies. Now really there probably isn't anything in there. Oh, so it's going. So let's right mouse click on the databases and click refresh, and there it is. So we know that the start date and the modified time, so we know it really completed because there really wasn't a big database. It was a small 1 gig database without a lot of data in there, but we see that the transaction actually happened and that it actually did create the database, and we see the resulting database right there, and we see the, well, not the views, we see the table. So what's happening is it's still copying the data. So it's still copying the contact table from our AppDev2 database. So if we wait a few minutes, we will see the contact table, because it is copying 20,000 rows. So that might take a few minutes. So we can come back later and take a look at this. Let's refresh to see if it's still done. So it's still copying. So it's 99% complete. So it's almost done. When we first executed this, it said 0% complete, so it still had started the data. So it's not quite done yet. It is 99% complete, so we got lucky there. Let's execute it again and see if it's done. Okay, there's no more rows there, so the copy is done. We can refresh. There's our table. So if we actually do our new query window, AppDev3, and do a select star from contact in our AppDev3, there's all 20,000 rows, almost. So it's still executing, but we should get all 20,000 rows. So our database copy did work, and it took about 10 seconds, 15 seconds to copy that one table and all its 20,000 rows. So doing a database copy is as simple as doing a create database name as copy of source database. In this example, I'm going to illustrate how to use the SQL Azure Data Sync to sync one database to another. For this example, we don't need our SQL Server Management Studio, so I'm going to minimize that. What we do need to do is we need to go to the SQL Azure Data Sync portal. So this portal is located at www.sqlazurelabs.com. And keep in mind that the SQL Azure Data Sync is in CTP preview, meaning it is not released yet, but you can sign up for it and can sign up for the CTP and can use it. But it is worth demonstrating, and that's what I would like to do in this demo. So once you go to sqlazurelabs.com, it will ask you to log in with your live ID, the same ID that you created your Azure account with. And once you log in, you'll be brought to this page. And the tab that we want to work with is the SQL Azure Data Sync. So as soon as you click on that, it'll take you to this page and ask you to create a sync group management. So very simple. We're going to click the Add New because we're going to create a new sync group. So as soon as we click Add New, it's going to say, okay, what's your sync group name? So we're going to just simply call this Contact Sync. What we're going to do is synchronize the contact table from the AppDev2 database to a new contact table in our AppDev database. So we're going to go from AppDev2 to AppDev. What I want to do is I actually want to grab that name, so I'm glad I'm here. Okay, so it's Contact Sync. Click Next, and it's going to say, where do you want to sync from? Or so what is our member information? We need to specify the members that we want to sync with. So we can't pick a server because we actually haven't registered any. So to do that, let's just click Register. And we're going to enter our server name, and we're going to enter our username and password. And this, we're going to go back here. Actually, we're going to go back to our portal, actually. We're going to grab the username, which is AppDevAdmin. Whoop, I want to go back there. So AppDevAdmin and the associated password. Now keep in mind it says that our credentials will be in encrypted format, so that's good. So let's click Save. And there we go. So it it registered our database, or our server. There's our server and the associated databases that we want to sync with. So what we're going to do is we're going to create a new hub. So our AppDev2 is going to be our hub, meaning our master, our source database. We're going to click Add Hub. And then we want to click a new member, meaning it's a database that we want to sync to. And we can have more than one, obviously. We can have one hub and many members. But we're going to sync to AppDev, and I'm going to add that as a member. As soon as we're done, so we've got our member list. There's our hub, and there's our member, AppDev2 and AppDev. And we just simply click Next. And then it says, all right, what tables do we want to sync? So we only have one, obviously, so we're going to sync that table, and then click Finish. There's our sync group. So we created our sync group when we defined our source database, which is our hub, and our member database, which is going to be the database that we're going to sync to. So we have several options at this point. We can select this, and we can say Sync Now. We can actually delete this sync group. We can actually schedule a sync group, meaning we can define a schedule when we want to sync. And then we have the dashboard, which means if we click on the dashboard, it actually tells us the sync jobs, when specific syncs have taken place, and it allows us to click a sync and look at the sync details of that job. All right, so let's go back and let's select our sync group, and let's just say Sync Now. So it's processing, and what we'll see is it's scheduled. So let's look at the view log while we're waiting it to refresh. Let's click View Log. And we can scroll down and we can see that his start of the job and some of the other pertinent information. So we can see that it's retrieving some synchronization information from the hub, checking the scope, checking the endpoint. The scope doesn't exist, so it's actually provisioning the member server, meaning it's creating the schema on the member side. The sync is actually bidirectional. It's going to go from hub to member and then sync member to hub. So the first transfer was from member to hub. So it went from app dev to app dev 2. So there were no changes. Nothing was transferred. But then it went from app dev 2 to app dev. The hub wins, and so we can see that there were almost 20,000 rows changed. That's a fairly quick sync. So we can actually go back to our SQL Server Management Studio, right mouse click and click refresh. And we notice several things. We could also, let's also go back to our AppDev2 database and refresh those tables and take a look at that. So we're looking at several things. Not only did it sync our contact table, so if we go in here and let's create a new query and look at the data in there, select star from contact. Okay, we see that it did sync the nearly 20,000 rows, but it also created several tracking tables in each database, right? So there's the contact tracking table, the schema info, the schema config, and the scope info. These are tables that the SQL Azure Data Sync will use to track what needs to be synced. To look at the underlying architecture of the SQL Azure Data Sync, it is actually using the Microsoft Sync framework to do the data sync. So if you've ever used the Sync framework, these tables will look familiar. And these tables, and there's also associated stored procedures. Expand this out here in a minute. There we go. To look at what it's using and the objects it creates to be able to provide the very detailed synchronization functionality. So all this did is it said, okay, I'm going to sync, from AppDev2 to AppDev, but all it did is move the data from one to the other because there was no changes. So let's actually do something like this. This is going to AppDev. So let's modify. We're going to update contact, set middle name equal to Gustavo. What's a good middle name for Gustavo? Call him Jose, where contact ID equals 1. Okay, so we're going to change Gustavo's first name from null, or middle name from null to Jose. So let's execute that. And you'll notice that even though we executed the one row, 2 rows were affected. And that's because not only did it update the contact table, but it inserted a record into the contract tracking table to say, hey, a row has been updated. Okay? Now let's go back to, this was in AppDev, but let's go back to and down to AppDev2. Select star from contact. And let's update Humberto's middle name. So update contact set middle name equal to Paco, where contact ID equals 4. So we're going to update that. Same thing, it updated the contact table plus inserted a record into the tracking table. Okay, so if we were to, let's look at contact now on AppDev2, and we see that now says Paco. If we look at select star from contact on AppDev1, we see that Gustavo has Jose. So let's go back to our portal and let's sync this again, and we should see two changes: one sync one direction and one sync another direction. So we'll say sync now. We can view the log because it's probably completed. That should have been a very simple sync. So we say one that direction, and one from hub to AppDev2, and one from AppDev2 to AppDev. All right. So we should see, if we were now to query these, we should see this is in AppDev. We should see that Humberto now has a Paco middle name. There we go. Humberto now has a Paco middle name. Now if we go to AppDev2, we should see that Gustavo now has a Jose middle name. And there we go. Gustavo now has a Jose middle name. So there was a very simple example of how to set up SQL Azure Data Sync between two databases. One is a hub and one is a member. We could easily have added a third or fourth or fifth member database to sync those databases as well. We then made changes to both databases. The first sync took the data from contact and created the contact table in AppDev and copied the data. And the first sync also created the corresponding tables and infrastructure to enable the synchronization. We then made changes in both databases, one change in each, and then re-executed the sync. And those changes that we made were synchronized to, again, the sync is bidirectional, so the sync in one went to the other, and the sync in the other went to the one. So we were able to synchronize multi-directional. So again, a very simple example, but illustrates the power of the SQL Azure Data Sync.